Now, it appears that researchers have found evidence that liquid water currently exists on Mars. So, does this mean we are one step closer to colonising the red planet?
And what's happening to Rosetta's Philae probe that has been hibernating since November after making a spectacular, if bumpy, landing on a comet? Well, for more on this, we're joined by Dr. Maurice Jones, space flight analyst extraordinaire, if I might say.
Thank you.
Thank you for joining us.
Good to see you again,
Always
Miriam.
good to have you with us, Maurice. Now, let's start with Mars.
Okay.
Always fascinating, the great big red planet. Liquid water, how significant is this discovery? Is it a discovery yet?
It's not really a discovery. It's just the fact that with the chemistry and the physics, it could exist under some conditions, because if you put salt into the water, that lowers the physical properties of the water. It means that it can exist at a liquid state when the temperature and the pressure are different. We know about this on Earth. It's fairly basic chemistry. And the chemistry in the soil is right, so they're concluding that it could exist, but we still haven't found it yet.
Remind us, why is this potentially a sign that life exists or existed on Mars?
Okay, just think about ourselves. Most of our bodies are made up of liquid water, and that's true for most life forms. It varies depending on how much you have, but the key ingredient of life is water and liquid water. We know that there's ice on Mars. There's ice in the polar caps, there's ice underground, but the whole thing is if you're frozen solid, it's a bit difficult to be living and be active. So finding liquid water doesn't mean that you've just got the right chemistry. You've got the right temperature for having life as well.
Why is it so difficult to find water on Mars?
Okay, the big deal is the fact that in most parts of the surface, it's freezing cold. It's about minus 30 degrees Celsius, and you've got very low pressure. The atmospheric pressure is about 1% of Earth. And if you took a cup of liquid water and exposed it to those conditions, it would instantly vaporize. It would sort of boil in a fraction of a second. It would dissipate in the atmosphere, and you'd probably just have a very thin residue of ice on the bottom of the cup. So extremely difficult under those conditions. But if you get under the soil with the right chemistry, it could probably hold it together.